Good morning, everyone. I thank you for joining our webinar. Our today's webinar is about weathering steel in bridges. My name is Mike Thibault, and with my colleague Omer, I am responsible for the technical assistance and marketing for bridges at ArcelorMittal Stelligence. Together with our colleagues, we are going to provide you today insights in the latest development in the field of weathering steel. And before we start, I would like to inform you that you have the possibility to write your questions in a dedicated question and answer chat, and those questions will be then answered at the end of the webinar. So let's start now with a short introduction around. So the agenda of today is a short introduction into weathering steel in bridges. Then my colleague Omer will speak about the use of hot roll sections in bridges, the latest developments. Then Frédéric will talk about the use of heavy plates in weathering steel in bridges and recent projects. And then our colleagues Elena and Krista will talk about the corrosion-resistant weathering steel for saline environment. So let's start with an introduction into weathering steel. So weathering steel, first of all, the composition and the functionality. So what is it? So if we have a look at the product standards, so the EN 10025, we see that it is regulated in the part 5, weathering steels between the steel grades S235 and 460. For long products, products are regulated until a nominal thickness of 63 millimeters, and for flat products up to 150 millimeters. Weathering steel is a low alloy steel, so we have some copper, chromium, and also nickel and phosphorus in minor content in this steel. And this leads to an auto formation of an adhering and dense oxide layer at its surface, which is called the patina, and this under the influence of the environment, especially under the sulfur dioxide. So that the patina can form, we would need alternating wet and dry cycles. And this patina that forms will slow the corrosion rate. So it serves as a barrier, and it is able also to renew itself whenever it gets damaged. And because this patina forms itself, there is no need to paint or to apply any other corrosion protection on the steel. If we have a look at the chemical composition of weathering steel, we see that the copper content coming from electric arc furnace, so when it's produced out from scrap. What is added is a chrome, which we need so that the patina forms and also adheres to the base metal. The carbon is slightly less than for non-alloyed steels. However, because we add additional chrome, copper, nickel, and additional alloys, the CEV value is higher than compared to non-alloyed steel. This is what we can see in the table, an excerpt from 10025 part 5. The mechanical properties are the same as for non-alloyed steels, so the yield strength, tensile strength, and also the minimum percentage elongation at after fracture is the same as for non-alloyed steels. So the mechanical behavior is according to what you know from non-alloyed steel. Coming now to the corrosion behavior. So the corrosion behavior strongly depends, of course, on the environmental conditions. What is a decisive factor is the sulfur dioxide concentration in the atmosphere. Of course, a too high content would jeopardize the formation of this oxide layer, and therefore the threshold value to ensure the good formation of the patina is below 90 micrograms per meter cube. Considering now, at least in the European countries, that we have the industry has strong filters installed, so that the sulfur dioxide content is less lower than this 90 microgram per meter cube. So this should not be a problem for the formation of the patina. And here we see an example of the corrosion losses according to a study in the USA. So we see that over 100 years, depending on which environmental area we are, a more industrial area or a more rural area, we see that the losses is up to 500 microns. compared to an unprotected carbon structural steel, which at this stage would have already lost 1 millimeters of material. The design rules for weathering steel. So how do we design with weathering steel? First of all, what we have to take into account when designing with weathering steel is a thickness allowance, which depends on the corrosivity class. So this corrosivity class is, of course, a measurement, a qualitative measurement on the exposure of the steel. The higher the class, the more aggressive is the environment. And so we have to reduce the thickness because it's patina forms, and we have to reduce it because it will not contribute to the mechanical resistance of the steel sections. The thickness has to be applied according to the corrosivity class and independently of the country. So different countries have the different rules, but you see that they are quite similar for corrosivity class 3 and 4, which are the most corrosivity classes which we are using normally in Europe. And so we have to apply it for the steel surfaces which are exposed to the environment. So if the steel is in contact or embedded in concrete, you don't need to apply these corrosion losses. And also for the fillet welds, you have to apply a thickness loss. For the butt welds, of course, not, because you will design it according to the, let's say, weakest elements which are connected. For the rules, so it is fully covered by Eurocode 3, the design of structural weathering steel. So the same design rules as for non-weathering structural steels counts. Of course, there are also national guidelines that do exist. So we have the European guideline, and also, for instance, in Germany, the DAS-Richtlinie 007. In France, we would have the CEREMA guideline, which also should be consulted when using weathering steel in bridges. For the fatigue verification, so it's done according to Eurocode 319, so there's nothing different compared to non-weathering structural steel. However, what we have to consider for the details that you could see in the table A.1 of this, so for the plain material, due to the roughness of this patina, we have to reduce the detail category by 1 for detail category 1 to 5 in this table. For welded and bolted details, because here the presence of the geometrical notch of the bolt, of the hole, and of the weld seat is higher than from the roughness of the surface, we do not need to apply any reduction. So we take the detail category S for non-structural steel. As for non-weathering structural steel. The toughness requirements according to Eurocode 3110. So if you have a look at the table for the maximum permissible thicknesses for this steel, we see at the current version of this Eurocode Part 10 that it does not consider all the steel subgrades of weathering steel. However, in the new version, the new generation of the Eurocode, it will also cover the new steel grades S420W and S460W. Here you see the table, how it will look like in the new generation of the Eurocode, so you can determine the maximum permissible thickness according to the rules of Eurocode 3110. Of course, there are some application limits because, as I said at the beginning, the patina should form well, and therefore you have to respect some conditions and application limits. You should not apply weathering steel for parts which are always wet or humid, for instance, which are always on the water or which accumulates water, because then the patina will not form. Also for corrosivity class C5 or CX, which has a sulfur dioxide concentration of both 900 microgram per meter cube, you should not use it. And also if parts of the bridges are exposed to chlorides, like de-icing salt or spray, for instance, for bridges with a motorway overpasses, because then the beams could lay, or the steel in general could lay in the spray of the de-icing salt of the cars and trucks. In marine environments, you have the natural chlorides from the sea. The distance, for distance below 1 kilometer away from the sea, you should not use it. Of course, the national guidelines may differ depending on which sea we are talking, if it's the Mediterranean, the Northern Sea, or the Baltic Sea. And anyway, it is always recommended to check the national guidelines if there are no specific limits which are formulated. The detailing of weathering steel is also very important to avoid, of course, to have water stagnation or dirt stagnation. And here you see one example how you should, for instance, design the stiffness of the beams. So the stiffness should be in a way that it does not offer any corner where the dust can accumulate. The stiffness should be as in the right picture. Also, as you could see here, the stiffness should be turned in a direction that you have no dust accumulation. The same holds true that you should always leave it open on the bottom flange and incline the bottom flange so that the water and the dirt can be dripping off. And for the welds, anyway, this would be for bridges the case. You should ground flush it so that, of course, you have no local humidity which can be at the weld root. And also the distance between the beam should be at least as high as the height of the beam, so to have a good aeration and a wet and dry circle in the beams. And of course you should avoid that the water can drip along the beams and drip then on the bottom, because then it can accumulate some rust particles and leading to stains. Also, the leakage joint should be considered. So at the end of the bridge, you have this joint that the water does not drip on the beam, because anyway it will accumulate then loose rust particles and leave to stain. So you should apply a dripping nose as shown on the picture under good detailing, so that the water drips off before getting into contact with the steel beam. Also, the height above the road should be respected. This is a recommendation coming from France to avoid what we call the tunnel effect. So depending on the distance from the walls, from the road, and also the height of these walls, you should have a minimum clearance between the road and the bridge. So it can go up to minimum 7.5 meters, so quite high. And this is exactly to avoid this de-icing spray effect when the cars run below the bridge. Then also, to avoid the staining of, for instance, the abutments, you should have, let's say, a drainage which avoids that the water can accumulate these rust particles and get then into contact with the concrete surfaces of the abutments. So the bad detailing would be like shown above. On the bottom, you see how you should do it. So you should incline the wall of the abutment on the back of the bridge, so that the water can drip off, and apply a drainage system at the back of the abutment walls, so that the water can be evacuated without getting into contact. And if you do this correctly, as shown in the picture, you see that you will not have any staining of the abutment walls. And therefore, you should at least leave 50 centimeters between the steel girder and the backwards of the abutment walls, so it will allow to evacuate the water correctly and have a good aeration, so that you can also dry humidity which can be trapped inside these spacings. The same holds true also for the pier. At the piers, you should also apply a drainage system, so that the water can be evacuated properly without getting into contact with the pier surface itself. At the end of the bridges, it is usable to use, or advisable to use, dripping plates or weld seams, so that the water that normally then gets into contact with the wall, abutment wall, will drip off before, by having a weld seam, as you could see it on the picture below, or by welding some plates at the end of the lower flanges to evacuate the water. The fabrication, so first of all, if you see here the example of surface evolution within 5 months, without blasting and with shot blasting, we see that with shot blasting we get a much more homogeneous coloring of the surface. That's why we always advise to use sandblasting 2.5, so to have a regular patina and a uniform coloring. At the same time, the coloring will depend on the atmospheric environment and the time and degree of exposure. So it is not really controllable from in every detail. It depends on the time and on the environment finally. For the cutting, flame and plasma cutting can be done according to normal non-weathering steel, so it's the same procedure as for carbon steel. It's also a similar preheat temperature that you should apply for welding, so to avoid excessive hardening of the cutting edge. And of course, you should grind the hardened edges to avoid any cold cracking afterwards. For welding, all manual and automatic welding procedures are applicable, so there's no limitation. Of course, the base metal or the mechanical properties should be adapted to the base metal when we talk about the weld metal. For the outer runs, the capping runs, the weld metal should be compatible with the weathering steel properties. But for internal ones, which are not in contact with the atmosphere, you don't need to have these matching properties. There are weld consumables to be used when welding weathering steel, and this is regulated in Eurocode in the EN 1090 Part 2, Table 6. You see that depending on the process of welding, you have different options that you can select for the weld metal. Also, you should avoid to leave the part in place before welding, so you should remove it 1 to 2 centimeters away from the weld. And all joints should be continuously welded to avoid spaces for crevices that must be closed, so that you cannot have some water which enters by capillary effect into these spaces. Welding of weathering steel of different steel grades is possible, so you can weld S355W to S460W. A welding of weathering steel with other structural non-weathering steel is also possible, and the use of weathering steel in delivery condition plus M may also help to reduce the preheat temperature. So you see here that an example of what can be done. So here we weld, for instance, a compression plate in S400 in S355, sorry, to a normal steel beam in S460 K2W. So you can weld those different steel grades together without any problem. When we're talking about holes, so for the bolts, for bolted splices, for instance, they are regulated in Eurocode 311. We have dedicated values for weathering steel. So for the connection elements, structural bolts in weathering steel are available. We have to admit it is quite limited. So TCBs, for instance, stocking M25, 24 and M30 bolts. You could also use stainless steel bolts, because the mass is quite small to the mass of the whole steel girders, so that there is no significant galvanic corrosion that occurs. And under some conditions, you could also use galvanized bolts. Here, of course, you have to pay attention that you close and you seal the connections, not to have some crevices where water can get in. Otherwise, you have, of course, a galvanic corrosion from the galvanized bolts toward the weathering steel, so the zinc layer will be consumed. So for hot rolled sections in weathering steel, they are used in small and medium span bridges between 10 and 45 meters. You see here some type of bridges where they can be used: filler beam bridges, steel composite bridges, network arc bridges, truss bridges, and so on. So between 10 and 45 meters, they are economic. Here you see what is available in weathering steel for hot rolled sections. So you have them available up to S460W with a thickness of 63 millimeters. And my colleague Omer will now soon talk about the blue profiles which are available. They are not only available in weathering steel, but also in all other steel grades. And hot rolled sections are also available in low emission steels, X-carb, also true for the weathering steel. X-carb means that the steel is produced in an electric arc furnace using up to 100% green electricity and up to 100% of recycled scrap. And by using so, we can reduce the carbon footprint of the product significantly. As you could see here, for the hot rolled sections, for instance, we have an EPD for modules A1 to A3 with a global warming potential of 333 kilograms of CO2 per ton of steel produced. So some projects in Arcorox, which has been realized since the 2020s. So we have here a bridge in France, which has been destroyed and which has been quickly erected. The advantage was that the bridge was the bridge erection was very quick, because we didn't need to paint it and to wait to dry for the paint. So this was one argument to use here the weathering steel in this bridge. Then the first in Poland in S460W. A bridge over a river. So this is very common to use weathering steel over rivers, because you don't need to interfere with the river to repaint the bridge later on. Then we also had one where we used this X-carb, and compared to the initial pre-stressed concrete solution that has been foreseen, we saved for the material 35% of CO2 in the modules A1 to A3 by using weathering steel and X-carb. And then also the first network arc bridges, which was fully done, except of the hangers, of course, in weathering steel, again over a river in Poland. And also the ramps has been done in weathering steel. And also a German bridge over a railway in weathering steel, because also over a railway you don't need to block the traffic of the railway below the bridge when you have to repaint it, because you don't need to repaint it. And so we also offer some services. So at ArcelorMittal Stelligens, so we offer free technical advisory and support during the whole design process of your bridge project. We also offer free pre-designs with in-house pre-designed software, so we can analyze variants and see what is the best option for you. And we also offer the fabrication of the beams so that we can deliver them ready to erect on construction sites. So sawing, cutting, drilling, welding, and cambering can be done in our dedicated workshop. So to put it in a nutshell, so the chemical and mechanical properties of weathering steel are like the non-alloyed steels. The design of weathering steel is covered by the ECS, so the Eurocodes. You have to comply with the application limits, of course, when using weathering steel, and the detailing is essential that the patina can form. And the fabrication, welding, bolting is similar to non-alloyed steels. So this was my intervention, and I would now give the floor to my colleague Omer, which talks about the new steel profiles which are available in weathering steel.
Thank you so much, Mike. I'll just take a moment to share my presentation with you. Okay. I hope you can see my screen.
Yes.
Yes. Yes.
Very well. So again, good morning to all the audience. Thank you for joining. My name is Omer ANWAAR, and I'm also part of ArcelorMittal's Intelligence Engineering team. We're based in Luxembourg. So in the next 10 minutes, I'll show you how weathering steel bridges, which are already a low maintenance, sustainable choice, can now be built with noticeably less steel, thanks to the 3 new hot roll sections, which we have added to the range. So I'll cover what has changed, why it matters, and what it delivered on a pre-design, which we did for a bridge in Poland. So let me start with why it matters. So weathering steel, briefly, as also Mike mentioned earlier, is increasingly specified for bridges and for good reasons. It forms its own protective patina, so there is no coating to apply. So that's the takeaway from the first presentation. And just as importantly, low maintenance over the lifespan of the bridge. That in fact removes a whole stream of cost, the disruption, and the embodied carbon from the asset over its whole lifetime. What is new is on the supply side. We have added 3 new hot rolled sections to the HL 1100 family. And basically, they sit between the sizes you already know or may not. So the steps between the neighboring sections are now smaller. That may sound like a detail, but it has a direct consequence. You can match the section far more closely to what each span actually needs. And a closer fit means less steel for the same demand. So let's look at the HL family itself. So this is the HL 1100 family, and you see the weight per meter of each of the sections. The gray bars are the sizes that have already been available. The 3 orange bars, so the 366. So you see on the x-axis the name, the 366, the C, and the 466. These are the new hot roll sections. You can already see what they're doing. Basically, they are filling the wider gaps in the middle of the range, bringing the step between the neighboring sizes down to roughly 20 to 30 kilograms a meter. These are ordinary hot roll sections, same rolling process, same chemistry, same grades as the rest of the family, but now available in both high star and weathering steel. What's new is simply that the mill now rolls these intermediate sizes, so nothing changes in how they are produced, ordered, or fabricated. You just have to choose. You just have more sizes to choose from the sections available. And I would like to show you these 3 new sections. So here are the 3 new HL profiles, which are drawn to scale with real dimensions. I show you this because HL 1100 can sound a bit abstract, but these are 1.1 meters deep beams with flanges and web thicknesses as you see here. And these are substantial beams, and you see the increasing thicknesses of the flanges, which is happening as you go from left to right to 466. The point is that the optimization we are about to look at doesn't come from anything exotic. In fact, it comes from simply having the right rolled section available at the right size, for the right size. So how does a finer set of sizes turn this into less steel, you may ask? It comes down to matching the section to the demand. So with the core set of sizes, the nearest available section often sits above what a span actually needs. So say a span calls for a section between two catalog sizes, you force up to the next one, and then carry that extra steel along the full length of the bridge, span after span. With the finer family, there is a section closer to the real demand, so you carry only the steel you need. On any single beam, the saving may seem a bit modest, but it applies to every beam on every span, and that's where it all adds up. So let me show you that on a pre-design which I mentioned earlier, which we did for a multi-girder bridge. This is a pre-design we delivered. It was a road bridge in Poland having 3 spans, 27, 34, and 27 meters. It's a composite deck, which is just under 14 meters wide, resting on 5 girders in weathering steel according to 125 part 5. So we designed it twice. The standard solution uses the established sizes, so HL1100B in the end spans and the HL1100M in the center. The optimized solution, in fact, uses the new section, so the 366 in the end spans and C in the center. In each case, the new size is the one that sits just above the demand. So where before you would have had to jump to the next big one, same bridge, same steel grade, same everything else. In fact, the only difference is the section choice which you are making here. Both are complete valid design. So I'll just show you how they look like side by side. So what you are seeing here is the standard solution, which comes in at 179 tons of structural steel. The optimized solution, in fact, is with the new section and which gives a tonnage of 169 tons. This is around 10 tons lighter, which amounts to around 6%. So there is no other change in the bridge. And before the headline, the obvious question is, does the lighter one still pass? And just to iterate again, both are fully valid designs. Strength and serviceability checks were done according to Eurocode 4 Part 2, the fatigue according to Eurocode 319. And for all the sections, C3 corrosion allowance was applied throughout. Both pass every check. The optimized one simply gets there with less steel. So the 10 ton isn't a trade-off against performance. It's basically a clean saving. Just to show you again the saving. So the 10 tons which you see, what does it basically represent? First, of course, the less tonnage is a direct saving on your structural steel. And the second thing, importantly, is the less steel. It means that you have less embodied carbon on top of course, the low maintenance and the coating-free life weathering steel, which is already offering you. And thirdly, and sometimes it's easy to miss, is lighter beams are easier to handle and erect, which can mean that the smaller and fewer cranes are needed on site. So optimization helps the build, but also the bill. Finally, the 3 takeaways which I would like that everybody takes from this presentation. Firstly, the HL1100 family is now finer. 3 new hot roll section lets you match the section to each span and carry less steel. The second thing, this changes nothing in practice, in fact. So the same rolled product, same chemistry, same grade, same fabrication and transport, and if anything, lighter beams, and which makes the construction easier. And thirdly, you get the durability of weathering steel and a leaner, low carbon structure at the same time. So the message is simple. If you are building a weathering steel bridge, these hot rolled sections are available now in high star and in weathering steel. And of course, we would be glad to help you put them to work. The full range of the sections, HL family, is available in our catalog. You will find the link in the presentation. And I thank you very much for your attention.
Thank you very much, Omer. So now we will come then to our colleague Frédéric, who will speak about the use of weathering steel in heavy plates in recent projects. The stage is yours.
Yes, good morning. So my name is Frédéric MARECHAL. I'm also based in Luxembourg, in charge of the sales of heavy plates in Europe. So I'm very glad to give you some information and insights in the exciting world of heavy plates, and also some examples of bridges we have done recently. So I think you see my screen. So if we talk about heavy plates, just information on this. So what are we talking about? So the production of the production mill for heavy plates is actually located in the northwest of Spain, in the region of Asturias. The mill is more precisely in Gijón. And it's the big advantage is that this is a fully integrated mill. So it means that from the prime material to the finished plates, we produce everything there. And also this mill is located with a direct access to the port of Gijón and the port of Avilés. So it's of course very easy to get the prime material to produce the steel, and also very comfortable and easy to export then via a vessel and via sea. So when we talk about heavy plates, in this case, at least here in Gijón, we produce plates starting at 6 millimeter thick, and we can go up to a maximum 150 millimeter thick. So you see what we are talking about. So we then roll plates in width of up to 3.3 meters width, and in length maximum up to 25 meters length. So the maximum unit weight, plate weight, is close to 18 tons. So also to give you an information on the different applications for what we use these heavy plates. So you will find these heavy plates in the onshore and offshore towers. Of course, in bridges that we will develop further, but then also in offshore platforms or shipbuilding. Shipbuilding is actually also a big market for these kind of plates. And then other more diversified applications like pressure vessels or tubes, line pipes, or even yellow and green goods that you see on the picture on the right below. So the mill in Gijón produced the major grades for construction, such as the well-known family of S355. We can do it in normalized treatments up to 120 millimeter thickness. We also do the more difficult, more demanding grade of S460N also, in this case up to thicknesses of 80 millimeter. And we also do these kind of grades in thermomechanical treatment. This means, in short, that the carbon equivalent will be improved in thermomechanical. So this has a positive effect on the aptitude to welding. And then, and this is the, of course, important for our today information webinar, is we also produce plates, heavy plates, in weathering steel, so with improved corrosion resistance. And here you can also find the so-called popular classical grades like S355J2 plus N, for instance, W, this means weathering. So this we roll up to thicknesses of 100 millimeter thick. We also propose it, and this is very interesting, and a big market in France, and specifically also for the construction of bridges. So we propose it with the NF Acier, which is the French quality certification mark. And as I said, it's also interesting for gateways, for bridges, and so on. So we have a big experience actually in Gijón to supply this kind of grades, and we have supplied many thousands of tons, also more specifically in weathering steel plates. So for multiple projects in construction in bridges all over Europe and even in outside Europe exports, we are able to produce these grades. So of course, according to the Euronorm, to the standards, and we are also able to deliver it with an improved carbon equivalent. Again, this is mostly to ease then the welding operations for the steel constructor and for all the chain further and for our customers in short. So, and this is also something that you have already heard. So we are actually very proud in ArcelorMittal to be a pioneer and also among the best in class for the low CO2 steel, in this case for heavy plates. So what we have achieved in our mill in Gijón for heavy plates is something significant. So we managed to improve the carbon footprint with very impressive figures. So, so I won't explain it again because my colleague already did, but just to give you a short information on this. So we managed to reduce the CO2 emissions by today by more than 65%. So for every ton of steel that we produce, we generate CO2 of 0.9 ton of CO2. And this is now about to be improved to close to 0.8 ton of CO2 in the new EPD that we will have released very soon. And this is mainly thanks to the production of steel out of slabs. So this is the prime material. And to get these results, we produce the slabs only with electrical arc furnace. And these electrical arc furnaces versus blast furnaces, they are operated with 100% of green electricity. And we feed these furnaces with almost 100% of recycled steel, so what we call scrap. So this is really recycling and nothing else. And then, so these electrical arc furnaces are not exactly on the side of Gijón. We have to ship them and then to have it rolled in our mill. So at the end, with these results today of CO2 emission, we are really, for heavy plates, among the very best and the first one to propose this and for such an extended feasibility program. So with, in case of orders for X-Carb heavy plates, of course, we provide the usual mill test certificate, but also a specific certificate, which makes it very easy to have a traceability, a tracking of the material. And we also have since almost 3 years now an EPD, which will be renewed and improved in shortly. So this is actually what I wanted to show you, some examples of specifically bridges that we have done. In this case, the two first one are with weathering steels, with heavy plates in weathering, and also combined with an X-Carb requirement. So I mean that these plates are both weathering and also produced with this X-Carb process, saving 66% of CO2. So the first example that you see is a bridge that will be commissioned this year. So we have worked this with our colleague from Stelligence, and it's this bridge is it's a pedestrian bridge, a footbridge. It's close to Cologne, and it has been done together with a steel fabricator in Germany, recognized one, Trepels, and it's about the delivery of 360 tons of these weathering heavy plates, X-Carb grades, and also in collaboration with a close partner in Germany who is a very famous steel service center, Union Well, the first reaction that we already got from the steel fabricator is very interesting in the sense that they told us that they were impressed by the weldability given on these X-Carb weathering plates. So this is something very interesting and important when you know how much welding work are on these plates. The other example is a much bigger project that we did. This is in Canada, also with a close steel constructor we are working with in Spain. And here we are talking about more than 10,000 tons of this weathering steel produced in Gijón, ArcelorMittal Gijón. And so it's this Champlain bridge is close to Montreal, and it's one of the biggest bridges in North America. So it's almost 3.4 kilometer length, and the steel that we have provided has been used for key steel components such as supporting beams and also the so-called delta frames. The next examples I will go quickly over. There are more standards still X-Carb, but no specifically weathering. But I think they're also interesting to mention. It's also interesting to mention that we are now, since 1 or 2 years, really see a clear trend towards weathering steels in the tenders, also for private construction. So this is really something that we see now popping up and increasing the demand for weathering. And so, okay, but in this case, I wanted to talk also to present you this bridge in Switzerland, another pedestrian bridge. It's interesting because this is now proposed by the Swiss Center for Steel Construction for the specific Swiss 2026 prize award for bridge construction. So it was the first bridge built with low emission carbon, low carbon steel, and it was awarded to a well-known steel construction company in Switzerland, Sotas, and they were actually the pioneer to use this kind of material. So I wish them good luck to get this prize. It will be awarded soon. Interesting to follow. Another example is this bridge it's actually a double bridge in France, close to Grenoble, done with our partner there, the steel constructor Gagne. And this bridge is with this NF Acier, this typical French quality label. And the bridge will be commissioned by end of this year. And this is the last example, and it's the latest bridge project that we have taken just a few days ago. And here we are in Rhineland-Palatinate, so in Sinzig. And yes, this is both a cycle and pedestrian bridge. And here we have provided 200, or we are about to provide 260 tons of this X-Carb heavy plates from Gijón. And we expect this bridge to be commissioned in exactly 1 year. So I think this is all from my side. Thank you.
Thank you very much, Frédéric. Very interesting. And now we are coming to the last presentation of today about corrosion-resisting weathering steel for saline environment. So I give the floor to Elena and Krista.
Hello, good morning. I hope you hear me and you see the screen. So welcome to this session. Today we will present our new product under development. So our weathering steel with improved corrosion performance in saline environments. I'm Elena Di Silvestro, and I'm R&D Portfolio Director. So I manage steel products for energy and construction. I will introduce you to this new product, and then I will leave the floor to my colleague, Krista CAN DEN BERGH, also belonging to Global R&D, for more technical details about the performance of the product. So first of all, I would like to put this product a little into its context, explaining what we do within R&D. So we are 1,650 researchers, and our global budget is of 335 million. We are a global R&D, as I mentioned, so it means that we have research centers, R&D units all over the world. So if you ever need support, just know that we are not just limited to one region, but our scope is quite broad. And our R&D spending covers several activities, so all our processes, but of course our products as well. So you will see activities for mining, for our process, but also several products like automotive, construction infrastructure, and of course, general industry, where we also see energy. If we focus on a flat product portfolio for industry, as I mentioned, there are several activities which are included. We see indeed construction, energy, packaging, and green goods. We also have specialty plates. And what do we do in terms of R&D? Today, you will have some hints in terms of new products, in use properties. So basically, we try to improve our offer, enlarge our offer, but we also analyze deeply the behavior of our steel, so concerning use properties, which can be corrosion, fatigue, weldability, toughness, so all in use properties that concern our material. We also have steel application, as some colleagues showed in the previous presentation. So analyzing the impact of using our steel and the next generation of our steel into real life applications like bridges in this case, and of course customer support. So all the other questions that of course could come when using our products. So going now to the core of this presentation, we talked about INDA10, or more widely known as Corten steel, weathering steel. We, I think, provided several details about that in terms of chemical composition, in terms of behaviors and use properties, in terms of design. So I don't have to repeat, of course, but it's important yet to remember that this product provides excellent resistance to atmospheric corrosion, thanks to the development of a protective and adhesive patina. So we have several advantages. We have appealing aesthetics. We have also a wide thickness range because we go from very thin products to thick products. We have excellent corrosion protection, even at high temperature. Cost effectiveness, of course, with reduced maintenance, but also with less OPEX, because we don't need necessarily to paint weathering steel. So it goes also with life expectancy. And of course, as all steel, it's 100% recyclable. But sometimes we face some limits, as we saw with Mike in the introduction, because indeed the protection of steel structures against corrosion in saline environments is quite challenging compared to other kind of environments. So we focused on this, and we decided to develop a new product with improved corrosion resistance, particularly for these environments. So if we look a little closer to what's new, so we would like to now explain to you today this new product under development. We always focus on atmospheric conditions. This is very important, but saline atmospheric conditions. So we focused on coastal areas and also offshore areas. So you see here some example of potential applications. We have, of course, infrastructure, bridges, but we could have also buildings. We could have wind towers or poles next to the seaside, and we could also apply it offshore in offshore substations, for example. So where did we start? We started from an encounter problems. So we have harsh conditions induced by the high loads of chlorines in the atmospheres, and we need to protect our steel structures against steel corrosion, which is quite challenging, as I mentioned. So what we are targeting is a product with enhanced steel corrosion, and that could also bring a high added value in terms of the durability of the product, but also cost effectiveness of the product. So to give you just a summary before going more into the details with Krista, what's new? We defined an optimized metallurgy to meet demanding mechanical performance in use properties like weldability and corrosion resistance in saline environments. And so we started a journey of product development, which is quite structured. We have a structured quality journey inside ArcelorMittal. We have to meet stringent requirements of ISO and IATF certifications to ensure to deliver a robust product. So who meets the performance, who meets customer expectations. So where are we now? We validated the production of this product at our ArcelorMittal heavy plate mill. So we had industrial production. We tested the product performance in terms of mechanical characterization. So we targeted an S350 and 55 value in terms of mechanical strength, but we also tested the 520, for the moment up to 20 millimeter plate thickness, but we could achieve even higher thicknesses if needed, if required. We tested weldability, of course, and we got excellent Charpy and CTOD in weld material. And then we also tested extensively our material in corrosion. So we had, first of all, accelerated corrosion tests, but then we moved to outdoor exposure in medium and high saline environment and in different conditions. So we have just the material as it is, let's say bare steel. We also exposed painted steel, and we exposed as well welded steel with the outcomes that Krista will show just in the next slides. Maybe as a just a summary of the corrosion performance that we got after 4 years of exposure in medium saline environment, we saw an improvement in saline corrosion resistance up to 20% compared to structural steel, which is quite a good result. In terms of standardization, for the moment, since it's a new product, our product is included in the ISO standard 630 part 5, so structural steels with improved atmospheric corrosion resistance, which can be compared to 10,025 part 5, and it has been included, as you see, and so we'll refer to it with this code as S355 WSC, so weathering steel with improved corrosion properties in saline environments. So these provide a general overview. Of course, as I mentioned, these are product under development. We passed several internal steps and checks, and now it's time to test it also outside our ArcelorMittal perimeter. And so we are eager, of course, to have any customer feedback or to hear back from you if you see any interest for this product in your application. But before moving to conclusion, I let the floor to Krista for the technical highlight of the product.
Thank you, Elena. My name is Krista CAN DEN BERGH. I am project engineer in ArcelorMittal Global R&D Ghent. My domains are corrosion studies on metallic coatings, corrosion testing, and the development of corrosion protection of steel substrates. So I'm glad to share in the coming slides our new development, the saline-resistant weathering steel. So in product development, after testing mechanical properties and weldability, now we focus on the corrosion performance. So coupons of this new industrially produced saline-resistant weathering steel are exposed to accelerated corrosion tests, but also different real-life outdoor tests in specific environments. So the environments, they are classified in corrosivity classes, where you have different humidity and a different load in chloride. So here we split up the exposures depending on the corrosivity class. The first one is an exposure in the north of the Netherlands, and here we have C3 corrosion class. So here, our material, our new saline-resistant weathering steel, performs better than standard construction steels as the S355 MLO and S355J2. So now we are exposing up to 4 years, and we see an improvement of 10 or 15% comparing to the references. So if we move then to a more severe environment, where we have C3 up to C4, it's an exposure we have in the north of Spain, where we have more chlorides, and here the exposure is on a wind farm. If we look here to the corrosion performance, so the corrosion performance is expressed as material loss over time, so you can express it in corrosion depth or the corrosion rate. And we see here after 4 years that we have a lower corrosion rate of the saline-resistant weathering steel, up to 20% comparing to the reference construction steel. So this is a benefit where we really think that this trend, the decrease of the corrosion rate in function of time, will further progress in function of time. So if we move even more to higher chloride loads, we have a C4, C5 exposure also in the north of Spain. And here we see that we have also a benefit of 25% comparing to S355J2. And here we only have an exposure of 2 years, but we think the same trend will continue. We also do an exposure in really severe environments like the real offshore in up to CX environment. But here we have to take into account that the corrosion rates are for all materials up to 10 times higher than the current ones in C2, in C3 or C4 environment. So for the application, we really focus, or we see the most benefit in C3 up to C4 environment. So this is all on the exposure and a comparison with the reference structural steels. So if we now look closer to the saline-resistant weathering steel, the behavior comparing to the standard weathering steel, so like Mike explained in his presentation, there are application limits for the current weathering steel. So if you have a distance lower than 1 kilometer of the seaside, you cannot use the standard weathering steel, and then maybe the saline-resistant weathering steel can be an option. So what we see here, it's a result we have up to now from an accelerated corrosion test, but our author is running, so we will hope to confirm this result in the real author exposure. So we see in this accelerated corrosion test where we accelerate the humid dry cycles and to see faster a result than in the real author. So we see that after some weeks of exposure in this test, that we really have a lower corrosion depth for the saline-resistant weathering steel comparing to the standard Indaten material. So this is a promising result where the saline-resistant weathering steel can be a material close to the seaside where the current Indaten cannot be used. So if we look now to the material exposed in welded and painted conditions, so as we have seen, the material in structures, in bridges will be welded and in some cases also painted. We exposed these materials also in these conditions. In the welded state, we did an outdoor exposure up to 2 years in C3 and C4 and C5 classification. And we did it with different types of weld. So we did 4 types of welding with commercial welding wire, and we evaluated the corrosion behavior. What we have seen is that for all these 4 types of welds, that we have a similar behavior and a similar behavior as our bare weathering steel. So it means that by having a weld on the material, we don't have localized corrosion, or we don't have a higher corrosion rate than the bare material without the weld. And this can be seen in these 2 exposure sites. If we move then to the painted material, we see that in an outdoor running for now 3 years of exposure, we don't see a corrosion in the defect that we created in the coating. In an accelerated test, we have faster result, and this test has run for 22 weeks. And what we see is in the upper part of the images, you see the reference structural steel, and below we have our saline-resistant weathering steel. So if you use it in painted condition and you have a defect in the paint, you see that you have less delamination when our saline-resistant weathering steel is used, so which is a promising result in case that the material or the structure needs to be painted. So as we conclude in general of this material in still development, we see that it can be a suitable product for saline environments in coastal and even offshore applications. So we think on bridges, buildings, poles, wind towers, and offshore substations. And it's a life cycle cost-effective solution because we have shown the application in painted and welded condition, but actually the painting is not needed in all the environments. So we have environments where the material is protected by his stable patina and no painting is required. So it's a validated product at ArcelorMittal production. We have validated mechanical performance and in-use properties, and we see in different exposures that we have an enhanced corrosion performance. So to further finalize this development, feedback from real applications is of major interest. So you can always contact us. We are available to further discuss your specific needs and to have a look with you if this new product can be applied in your application. Thank you for the attention.
Thank you.
Thank you very much for your attention and for the presenters for those very interesting presentations and topics. I think the questions that were raised in the chat in the meantime have already been answered. I think everybody who asked the question got an answer. Also, a general remark that the slides will be made available then after the webinar. So, Elena, do you have also a remark about the C5 exposure for the saline grade?
Yes, so thank you for the question. I see, are you anticipating that the new weathering steel will be then allowed to C5 exposures? I would say that we got promising results in C4, C5 environments of medium-high salinity, but we need, so now as I mentioned, as Krista mentioned also during the presentation, we need more, let's say, real cases, real applications to verify this.
So yes, there's a last question that we can answer. It's about the weathering steel for bridges over highways. Can you explain a bit more in detail the limitations, the distances, and so on? Yes. As I showed in the slides, there is a height limitation that you should respect if you would use the bridges over in weathering steel over a highway, especially to avoid this tunnel effect when the spray, the de-icing spray, will be ejected on the side horizontally. But if there are, of course, walls, it will go up and get into contact with the beams. And because the beams are below the concrete slab, the de-icing salt is not washed off. And so you will have, like in winter, especially in winter, a permanent exposure to this de-icing salt because it is not washed off, and this is quite critical. That's why the limitation, this is a formula where you can calculate it, but we are talking about 7.5 meters. That's why we say the weathering steel bridges are more common over rivers or over waterways. Of course, not over the sea, especially if you have saline, the saline rate or the saline grade of weathering steel, and over railway lines where you do not have an exposure of de-icing salt from below the bridge. So I hope this answered the question. Anyway, if there are more questions, you can now anyway contact us after the webinar. So, and I think we are now at the end of the webinar, so I would like to thank you all, the attendants, for joining, and I wish you a nice day, and also a great thank you for the presenters who make a really nice presentation today. So thank you very much, and have a good day. Bye.
Thank you. Have a good day.